Welcome to another Ask Me Anything event. If you're watching this on YouTube, I invite you to join me live next time. We have these every Saturday at 11 a.m. Eastern, and you can join for free by starting your free trial on quantreasoning.com.
So I think there are two elements that make this question particularly tough. The first is the words at least, which of course is an inequality, so that increases the complexity of the story that they're telling us. And the second element that makes this harder is this modifier in the second statement. These kinds of modifiers with percents in overlapping sets questions always make it much harder. There's a very common mistake that people make there. So let's go through this. It is an overlapping sets question. We've got the students who study Japanese and those who don't study Japanese. And then on the other end, we've got the students who study French and the students who don't study French. Of course, there will be an overlap for those students who study both. There'll also be the students who study French but not Japanese, the students who study Japanese but not French, and the students who study neither of those two languages. So we have a lot of moving parts here, and the strategy that I would use for a question like that is Carroll diagram. And why don't we decide to have the columns for Japanese and not Japanese, and we can use the rows for French, not French, and total. Now with the at least 100, I mean, if it said 100, if it just said 100 students, I would just put 100 in the appropriate place. But with at least 100, there's no upper limit. It could be 1,000,000. So I'm thinking of doing something like greater or equal to 100. But maybe the best bet is to just use a variable. Let's call it X. Let's say there are X students who study Japanese. So the X would go here. And we'll make a note that X is at least 100. Let's make that note over here. X is at least 100, or greater or equal to 100. So that's the free info. But there's a bit more free info, right? We're told that 4% of the students, and I actually should have highlighted that as well. There's another tricky modifier here. Of the students at the school who study French, right? So it's not 4% of everybody. It's 4% just of those students who study French. So where do we have the students who study French? That would be here. I don't know what the number there is, so I'm going to call it Y. Just use another variable. We'll call it Y for now. Of those Y students, 4% would be in here in the both and cell. So we'll call this Y, and we'll call this 0.04Y. So that's all the free info. And the question is asking whether or not more students study French than Japanese. Well, we have Y for the number of students who study French. We have X for the number of students who study Japanese. So now we can rephrase the question to, is Y greater than X? We just want to know which of those two variables is greater. So now we've taken all of the free info into consideration, and we've rephrased the question. Which statement will I start with? I like to start with whichever statement seems easier, and in this case, I would say that that's statement 1. Statement 1 gives us the actual number for this cell, for the both J and F. So we know now that 0.04Y equals 16. We should be able to infer the value of Y from that. The question was, is Y greater than X? So we have now the value of Y. Do we know anything about X? We know it's at least 100. So do we actually have to find the value of Y now? Or is it enough to just say, I could find the value of Y if I wanted to? That's the danger with inequalities. With inequalities, something might appear to be insufficient, but then If the question is asking an inequality and you also have information about an inequality, it may or may not be sufficient. Just to give you a very simple example of that, let's say that I want to know, is m greater than 10, okay? And then I tell you that m is greater than 5. Is that sufficient to answer the question? No, just because something is greater than 5 doesn't necessarily mean it's greater than 10. It may or may not be greater than 10. On the other hand, if I told you m is greater than 20, would that be sufficient to answer whether m is greater than 10? Yes, of course. If we know something is greater than 20, of course it's greater than 10. So that's the danger with data sufficiency in the context of inequalities. An inequality may or may not be sufficient to answer a question about an inequality. If we discover that the value of y is less than 100, that would be enough to answer the question, because we know x is at least 100. So in this case, we actually do have to go ahead and find the value of y. We don't need to find the exact value of y, we just need to know which side of 100 it's on. And in this case, I mean, if you're told that 4% of something is 16, does that mean that that something has to be more than 100? Yeah, right. 4% of 100 would be 4. So 4% of what would be 16? More than 100. It would be 400. You're right. But I don't even need to go that far. Enough to say, look, this thing y has to be more than 100 if 4% of it is 16. Because if it were exactly 100, 4% of it would be 4. So that's good enough. Now we know for sure y is more than 100, and that means we can't answer the question because y is more than 100, x is more than 100. Which one is bigger? I don't know. So statement 1 is not sufficient on its own, and we should go ahead and eliminate the answer choices that claim that it is sufficient on its own. So A, D are gone, and we're down to B, C, E. So statement 2 is the more challenging one. It's telling us that 10% of the students at the school who study Japanese, so of those, of X, 10% also study French. So now we can go ahead and put 0.1, I'll just do 0.1x goes in that both and cell. Now I don't know what x is, I don't know what y is, but I do know that 0.04y is exactly the same as 0.1x. Can you tell from that relationship? Let me write it here at the top. Technically speaking, if we didn't know that x and y are positive numbers, we would say from this equation that y must be farther away from 0 than x is. And we'd say they're both on the same side of 0. Right, so that's if we didn't know anything about x and y. In this case, we can say that x and y are positive integers because we have a story about students. So not going to be any fractional students. But in general, when you have an equation like this, you'd say y has to be farther away from 0 than x is, and also they're on the same side of 0 because we can see that they have the same sign. In this case, we know they're positive, so we would say that y has to be the bigger number. Again, because it has a smaller fraction of it versus a bigger fraction of x, and those two things are equal to one another. So that must mean that y is the bigger number, and that answers the question definitively, and therefore the correct answer is B. We have a cost of manufacturing that depends on 3 different things, and we call them R, S, and T. Interesting that when the T is squared. So what I take from that is that if T is doubled, the cost of manufacturing will get multiplied by 4. If T is tripled, the cost of manufacturing will get multiplied by 9, and so on. I'm also noticing that there's a positive correlation between each of those elements and the cost. So when R goes up, C goes up. When S goes up, C goes up. When T goes up, C goes up. Now, we're given some percent increases, and the question is also asking about a percent change. In a previous AMA event, we talked about translating percent change to a change factor and then translating back from change factor to percent change at the end. I'll link to that other video above me and in the description below. But just as a quick reminder, to convert from a percent change to a change factor, we just take 100 as our starting point. That's the easiest starting point to use for a percent change. And then we figure out the number after the change. So for example, a 20% increase takes us from 100 to 120. And that ratio of new number to original number, that's the change factor. So a 20% increase means a ratio of 120 over 100, or 6/5 once you've reduced. So that's what we're going to use to solve this question. We have a 50% increase for R, which means we're going from 100 to 150, meaning we're multiplying by a change factor of 150 over 100, or 3/2. And S has a change factor of 6/5. So I'm just going to make a note here of what we're multiplying by. So we're multiplying by 3/2. We're also multiplying by 6/5. And finally, we're multiplying by, what does it mean? A decrease of 30%. That means we're multiplying by 7/10, right? Because there the new number would be 70 over 100, or 7/10, but we're doing that twice. So times 7 over 10 and another 7 over 10. And the reason we have that twice is because of that square on top of the t. So these are all the change factors that are happening to our cost. And what we want is a percent change. So how do we go back from change factor to percent change? Again, a quick reminder, we use 100 as the starting point for the same reason that we used 100 earlier. That's the easiest number to use for percent change. And we say, if I started from 100 and then I multiplied by all of these change factors, that would give me my ending number. But if I want it as a percent change, I need to subtract back out that original 100. So that's the trick to going from change factor to percent change. We'll multiply this whole thing by 100. I'll just put the 100 here at the beginning. And then when we're done with all of that, we subtract back out the 100, and that should give us the percent change. So we now have the correct answer in front of us. We just have to simplify it so that we get a number that looks like the answer choices. But this is the correct answer. To be technically correct, I should also put a percent symbol at the end there, because that whole thing is a percent change. So if this results in something negative, we have a percent decrease. If it results in something positive, we have a percent increase. So let's start solving. I do have two factors of 10 in the denominators there, which we could reduce with a factor of 100. And it looks like what we're left with there is, in the numerator, 3 times 6 times 49. Right? The two sevens is 49. And then the denominator, we have 10, a 2 and a 5. So it's a 10 in the denominator. And then we'll subtract 100. Now, there are many different ways you could multiply out 3 times 6 times 49. Personally, I would think of it as 18 times 50 minus 1. That's how I would do it. So 18 times 5 is 90. The way I did that is 18 times 10 is 180, so half of that is 90. So 18 times 5 is 90. So that's 900 minus the 18, right? 1 minus 18. So whatever that is, right? That's 882. And let's not forget to divide by 10. So it's 88.2 minus 100%. That's the answer. I really think here we probably want to start by just focusing on this part and hopefully translating that into a ratio. what do you think that ratio should look like? If something includes 15%, what would be your numbers for the ratio? So that's a really good idea to use 115 and 100. The question is, how do you know whether it should be 115 and 100 or 185? Because I think about half of the people would use 85 and 100, and half would use 100 and 115, and that's not the same, because the ratio of 100 over 85 is just a different number from the ratio 115 over 100. So one of them is correct and the other is incorrect, and it's like, well, how do you know which one is right and which one is wrong? How do you decide? Well, how do you know that in your equation you should use 115 over 100 rather than 100 over 85? So I guess what you're saying is, look, I've been at a restaurant, I've left gratuity, and the way I computed that gratuity in my calculator was based off of the price of the lunch pre-gratuity, not post-gratuity. How could I calculate 15% of the total price if I don't know what the total price is yet? And the whole reason why I'm calculating my tip is because I I mean, I don't know what the total price, including the tip, is. I'll find out once I figure out what the tip is. So when we punch the numbers into our calculator to figure out the tip, we're punching in the price excluding the tip, or the price for just the meal, and then we multiply that by 0.15 to get the amount of tip we need to leave, and then we get the total amount after that. So you're right. So I think that's the way to decide whether the 15 should be off of um, the total amount or the pre-tip amount. So let's say that we have just the meal, we have the gratuity, and we have the total. So I'm building a ratio here, and the numbers will be 100 for our starting point, then 15 for the gratuity, and then 115 for the total. So now that we have that, what do you think I should do next? Do I keep reading the question, or is there something else I could do now to simplify things? Is there perhaps a common factor that we could remove from the ratio? So what would we have once we've removed the common factor? We'll have 20, we'll have 3, and then the total would be what? 23, just adding them together. And now I'm ready to receive this actual dollar amount that they gave me. I wasn't ready for it until now. I think a lot of people just take it and do something with it just because it was given. But you're in charge. You tell the GMAT when you want it. You tell the GMAT, okay, now I'm ready for it, and it belongs in the total. Now I'm keeping in mind I'll still want to divide by 15 at the end because the question was about just one person. So I will have to divide by 15, but I don't want to do that yet because 207 is not a multiple of 15. They're asking excluding the gratuity, so what we're interested in is this number here. And once we find it, we'll divide by 15. So I think I'm ready to write down my final answer, which is going to be 20 out of 23 multiplied by 207 divided by 15. So the takeaway there is once you have a ratio, always reduce to the smallest integers that fit, because that's the whole beauty of a ratio, is that it's a simplified model of reality. So you want to make it as simple as you can. Any thoughts about how to divide 207 by 23? Perfect. Someone's been watching my videos. So this is the answer. We just want to figure it out. And Lucia had a great idea for dividing 207 by 23. She thought, well, what's a number that I know of that is an obvious multiple of 23 that's somewhere in the neighborhood of 207? And the number that she thought of was 230. But then you have to fix it, right? Because it's not 230, it's 207. So how do you fix it? How do you get back to 207? Oh, how about that? You just have to subtract 23. So that works out perfectly, and the answer is 10 minus 1, or 9. So that's 9. And so then what do we have left in the end? We have 20 times 9 divided by 15. And again, I would ask you, Eric, are there any common factors? Is there anything we can reduce when you have 20 times 9 in the top and 15, or 5 times 3 in the bottom? And the 5 from the 20? Perfect. And there we have it. So as is the case for most GMAT word problems, there's a kind of quick and simple way to solve this, and there's more complicated ways of solving this. I'll just share with you the quick and simple way, because you can find the longer approaches elsewhere, and I don't think that they're that useful to learn from. The quick way is to really focus on the dollars going out and the dollars coming in. The dollars going out was $600. That's how much we spent. And we're looking for the gross profit. So if we can figure out how many dollars came in altogether, take out from that $600, we have our answer. So I'm really going to focus on the dollars coming in, because I already know how many dollars went out. And so then I'm told that for 2/3 of the product, for which I would have paid $400, because $400 is 2/3 of $600. So for those $400 that I spent, I had a 25% profit margin. What's 25% of $400? It's $100. A quarter of 400 is 100. So I must have sold the first $400 worth of product for $500. So that's $500 coming in. From the first $400 spent, I got $500. That part, I think, is the easy part. Then comes the more complicated part, which talks about the remaining $200 spent. Here I have to think just for a moment, what would I have sold that for if it was the same profit margin? If it was the same as the first $400, then I would have got, what I'm about to type is a mistake, I'm about to type a lie, but I would have got $250 if it was the same 25% profit margin. However, I'm told that I actually got 10% less for that part. So what's 10% less than $250? I'm going to fix my mistake now, which would give me $225. Because 1/10 of 250 is 25. Take away 25, I'm left with 225. So we spent a total of 600, but we brought in a total of 725. So that's an extra 125. I don't know why it's selecting 3 answer choices, but I meant to just do, there we go. $125. The definition of gross profit is revenues minus costs. So if our costs are $600, I can figure out the revenues and then subtract from that the cost, and that will give me the gross profit. Does that answer your question? I'll just highlight the word, where are we? The word sold for. That's why I attributed the 10% less, or I applied it to the amount of money that I actually received for those $200 worth of cabbage heads. To Lucia's question, the reason why we can apply this to this, the 2/3 to the $600 directly, is because of all of those modifiers. So it's because of the yellow modifier and because of this modifier. if the cabbage heads were all different, if there were some really big, juicy, expensive cabbage heads versus rotting, 3 months old, tiny, dried up cabbage heads, then we wouldn't be able to just assume that the $600 were just spread out evenly among the 1,500 heads of cabbage. And if we can't assume that, then we can't assume that the 2/3 of the 1,500 that we sold accounted for 2/3 of the $600. If those 2/3 were really nice, juicy cabbage heads, maybe we actually paid $550 for those 1,000 and only $50 for the remaining 500 cabbage heads that were disgusting. I'm trying to think about what tip I can give you so that you'd be able to do in the future what I did here. And I think the best tip is to slow down your reading. I think people generally read way too fast on the GMAT. And if you ever see the speed at which I read, you'll laugh. You'll think I'm joking. I read very, very slowly. And I pause a lot and I think about what it means. And then the other thing is I pretend that it's my money. I just spent $600, right? And the minute it's my money, somehow it makes it easier to focus on the money and not focus so much on all these modifiers and the cabbage and be just more focused on the money instead. How much money am I getting back for my $600 investment? And so I'm really focused on that. And then I'm thinking, well, if I got $500 for the first $400 spend, then with the same profit margin, I'd have received $250 for the $200 spend, just looking at that ratio. And if I gave a 10% discount, then I actually didn't get $250, I only got $225. And then I just look at, okay, how much money came in? A total of $725. How much did I spend? $600. What's the difference? Done. So I think those are the tips, right? Number one, pretend it's your money. Number two, read a lot slower and just think in a very everyday kind of way. Like a grocer in the market would think the way I thought. An analyst at an investment bank wouldn't. An analyst at an investment bank would probably do what you were doing, Eric, which is a 4-minute solution with an Excel spreadsheet. But the guy selling cabbage heads at the grocery, at the marketplace, would probably think about it the way I did. And that's really what the GMAT is testing, because they know that you're all good analysts. Almost everybody taking the GMAT is currently working as an analyst of some kind at some company. So they know you can be analysts. They want to see, can you not be an analyst anymore? Are you ready to go to the next level? And so they design these questions to punish analysts and benefit people who wouldn't even go there and would just think about it logically.
If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.